Have you ever wondered how come the double-decker bus is not yet tipping over? Well, basically that is related to the center of gravity. Bismillah, Assalamualaikum warahmatullahi wabarakatuh, and today we will be having the tutorial relating to center of gravity, center of mass, and centroid. In the previous tutorial, we have covered how to determine using integration. For this tutorial, we will be dealing with composite bodies. Before we move on to our tutorial, let's go back to the case of the double-decker bus there, right? So, logically, right, is it possible that the bus is not yet tipping over in such an angle, right? So, perhaps our logic, right, in looking at that and saying, most probably that will tip over already, right? That is being influenced by our daily dealing with things that is homogeneous in nature, right? So basically, if you have a block in that dimension, right, in that angle, the center of gravity will be something like that, right? And if that is the center of gravity of the bus, and if you draw the force downwards, and if you determine the moment about the point there, at the tire there, then it will create a moment, right? A tendency for rotation in that way. Hence, obviously, it will already tip over, right? But if the center of gravity is low enough, for example, at that point there, and then if you draw the force downwards from that center of gravity, and if you consider the moment about the same point there, the moment or the tendency for rotation will be in that direction, right? Hence, despite what it seems to be logically tend to tip over, it is actually the gravity itself is stabilizing the bus, preventing it from tipping over, right? So that's how to say, the location of center of gravity is important in terms of determining how stable, for example, this double-decker bus is. In our daily life, perhaps we can relate it to this, right? If we put a block of very heavy steel like that, and then we put on top of it featherweight material like styrofoam or something, on top of it we attach it, and then another on top of it, until something like that, it will not tip over, right? Despite the dimension, right? So because we know the heavy part is the steel down there, so from there you can relate to how the bus is designed, right? So that is also related to what we will be dealing with today, right? So this is composite basically, right? So in that case of the block of steel attached to styrofoam, for example, it is combination of different material with different density, which makes the location of center of gravity is very much within the area of the steel. Hence, we can expect it will not be tipping over, right? Despite the centroid is much higher, right? So, having said that, we will go straight into our lesson for today: how to determine center of gravity, center of mass, or centroid of a composite body, right? So, basically, the difference is basically, composite body is where you separate the whole body into smaller parts, right? So that's basically the concept. And if we deal with basic shapes, then we do not need to integrate, right? Because we know for square, for rectangle, for triangle, we know exactly where the location of the centroid is, right? But the same concept, the composite body, you can also apply for shape that would require integration, right? And perhaps we will go into one of those example later on, right? So without further ado, let's go to the first question. Oh, by the way, before that, if you need the question that we will be covering for this tutorial, it is in the description box below. Feel free to download and just take a look at the questions. And as usual, we timestamp this video. If you see the timeline down there, to the question, so you can straight away go to the question that you want to to learn about. All right, so without further ado, let's go to the first question. Okay, in this question we have the area of the shapes there given, the shaded area, which is a combination of a triangle, rectangular, and then there's a whole of a circle there, right? So the dimension is given, and the question says, determine the centroid of the shaded area in the figure. First thing first, what is the question asking for? So basically it is requiring us to find the centroid. So we have this is 2D, right? So we have the equation where x bar equal to summation of, for centroid it is based on area, right? So that is the equation for x, and of course similarly for y. Hence based on this, we will just normally in this chapter, right, we just make a table and then solve this accordingly, right? So that is the best way to present the answer in the exam, so that it's easy for you to track down what is being calculated, and for the examiner as well, right? So based on that, so basically in the table we will have let's say the segment or the section, right? And then we have the area, and then we have centroid x, centroid y, and then the multiplication xa, and then ya, right? So that will be the column of the table. How come? If you already know what equation you want, then obviously you know what column you have to have, right? So for example, you have a, so obviously you have a, and then you need xa, so you need x and a, right? So first you establish x, so you can multiply this, you get xa, you need ya here, so you establish y, and then you can multiply y with a, becomes ya. And then in the end here you can have the summation of all, so summation of a here, summation of xa here, summation of ya here, right? So it's logical in terms of how to make the table, right? Okay, so in terms of the shape, right, so hopefully this is enough in terms of space. Okay, so if we divide it already, so it will be something like this, and then we have a hole there, right? Okay, so we have to label properly. So let me label this as 1, 2, 3, right? So shape number 1, shape number 2, shape number 3. 1 is the triangle, 2 is the rectangular, 3 is the circle, right? So with that we can start, right? So obviously make sure you remember that this will the whole thing will be number 1 plus number 2 minus number 3, because number 3 is whole, right? So segment number 1, segment number 2, segment number 3, right? So what is the area of number 1? Is the area of this triangle, right? So half times, okay, what is the dimension? So if I'm using millimeter, right? So I'm using millimeter. You can convert to meter as well, right? So as long as you're being consistent. So here it is 300, right? And then the height here is 200, right? Okay, so this is 300 multiplied by 200. Okay, is it too small? Hopefully you can follow, right? As I verbally mentioned. So this is basically just the area of the triangle. Half times 300 times 200, and then you should get something there, right? So it is 30,000. Right, this is in millimeter square, right? So okay, we'll settle the area first. For number 2, it's just the rectangle, and then this is 300, right? This is another 300 here. So it's basically just 300 times 200. 300 times 200 becomes 60,000, right? And then this one is the circle. So pi r. So r is 75. So the r is given as 75 millimeter. So in terms of millimeter, so pi r square. So 75 square. So it becomes, okay, this will become negative, right? Because the area is negative. So it will be what? What is it? 17,671. So minus 17,671.5. Right, 17,671.5 is if my calculation is correct. Right, so that's the area. Alright, so for x, this is the centroid, right? Remember, a thing to remember, this is the coordinate, right? It's not a distance, it's a coordinate. So coordinate is based on the axis, right? So for x wave, x wave, basically, the centroid is somewhere here, right? So the x is 2/3 of this length, so this one should be 200, right? 2/3 of 300, based on the ratio of 1/3, 2/3. Hopefully, you are already familiar with the ratio by now. So this will become 200. What about y? This one, so it's 1/3 of the height. Height is 200, so 1/3 times 200, right? So here 1/3 times 200. That is the y coordinate of the triangle, right? Okay, what about the area 2? This rectangle. So it is at the center, is at the center here. So what is the x coordinate? So this one is, okay, this one is 150, right? Half of 300. But the coordinate should be, you have to add this 300, right? Because the coordinate, right? So it becomes 450, right? 150 plus 300. And then the y coordinate, this one is just 100, right? Half of that. So this is 100. What about this circle here, right? So it's basically the same coordinate here, right? Because it's basically the same centroid. So it will be 450 and then 100. Okay? And the rest is just calculation. This is just purely mathematics. So if you calculate this one, you just calculate this one is just multiplication, right? So for example, 30,000 multiplied by 200 becomes 6 million basically, right? So in this case, if I write in a different color back again, this one becomes 6 million and so on, right? So based on those calculations, then you can calculate what is here, right? So what we need is summation of A, which is here. This is summation of A, right? And then you need summation of XA and also summation of YA here, right? So it's just adding up. So if my calculation is correct, if you add up this thing, you'll get 72,328.5. Okay, and then this one, if my calculation is correct as well, this will become 25,047,825. And this one, it is okay. Now note that because this is negative, so this one will be negative here, right? And this one will be negative here as well. So make sure you double check that one, because when you multiply negative with the distance here, you get negative something here. Negative with the distance here, you get negative something there, right? So again, here is 6,232,850, right? So based on these numbers, then you can apply straight away this equation. It's just plug and play, right? So based on that, if you go, where should I write? Should I use down here? Is it Okay, if I use down here, so x bar is basically this one, 25047,825 divided by 72,328.5, and then you will get something like 346.3 millimeter, right? Do some reflection whether this is logical or not, right? Because if we make serious error, then sometimes the number already indicate that something is off. It doesn't mean that if it's logical, it's always correct, but at least we can identify if it's totally illogical, right? 346 is around here, right? So it's logical, right, in that sense, because if you see the area, okay, it's somewhat logical. What about y bar? So this 6232850 divided by 72,328.5, and if you divide this, you'll get 86.2 millimeter, right? 86.2, so it's on the bottom half, right? So that again, that is logical, right? Because the area here shifting to the bottom side, so it should be towards the bottom side a bit. So 86.2 is logical as well, right? So so what is needed? The question again, determine the centroid. So the centroid is basically the coordinate of x bar, y bar. So it should equal to 346.3, 86.2 millimeter, right? So that would be the answer, right? If I'm right to write it down, 346.3, 86.2 millimeter, and that is your answer. All right, so pretty straightforward, right? So normally if you get question in in this chapter, especially if you have to determine using composite body, it is quite straightforward. You just do the table, calculate, and get the answer, right? So it should be straightforward, and this kind of question should be like the free marks. It is not free in the sense that you have to work for it, but it cannot trick you anymore except for if you make any mistake. For example, if you forget this negative, then of course it will affect this, and the whole thing, right? So that's among the thing. And sometimes also as well, the question can have negative coordinate, right? So for example, because here everything is positive, right? But if the axis is here, then this side is negative, for example, right? So in terms of the coordinate as well, it can be positive, it can be negative, because this is not distance, this is coordinate, right? So with that, we will move on to the second question. Okay, question number 2. You have the diagram there on the left, and then the question says the composite plate in the figure is made from brass, which is part A, and steel, which is part B segments, right? So if you see the diagram, you have the part which is labeled A and the part which is labeled B. Determine the mass of the composite plate and location of its center, its mass center. Basically, this is center of mass. And we need to find the x, y, z coordinate of this, right? And also as well as the mass, right? Take the density of brass is 8.74 megagram per meter cube, and the density for steel is 7.85 megagram per meter cube. And then there's part B here. Is the geometric centroid of the plate the same as the center of mass? Why? If it is different, determine the location of the centroid. Alright, so in this question, basically we have two parts of the question, and we will focus on part A first. And even part A, you have to determine the mass as well as the location of the center of mass, right? So what we need to find is, okay, center of mass, and the answer will be in terms of x bar, y bar, z bar, and as well as the mass itself, right? Okay, the mass in total. All right. So again, how to do this is just like in the first question. So basically, we make a table, right? So in the context of the equation first, so we have x bar equal to summation of x with m, with summation of m. Why? This is dealing with mass, right? So if you're dealing with area, then A. If you're dealing with volume, that's V. If you're dealing with mass, then M. If you're dealing with gravity, is W, right? The weight. All right. So similarly for Y, so we have y bar equal to summation of y with m over summation of m. So we have z bar equal to summation of z with m over summation of m, right? So from there you can see that we need more column than first question, because we have x, y, and z, right? So yeah. And in terms of the mass, right? So if I calculate the mass in the column, the column will be quite wide, right? So let's see. Okay, because when we do the table, so we have the segment, for example, segment, and then we have the mass, and then we have x with, y with, z with, and then x m, y m, and z m, right? So that will be our column, right? If we try to redraw it roughly, the object, so it's something like this, right? And okay, forgive the drawing, right? And then it is separated here, right? Roughly. Now, so in terms of the shape, the basic shape that we can consider, so this is exactly the triangle, right? But here, trapezium is not something that we know exactly where the centroid is, right? So we can just divide this another something like that, right? So that triangle, and rectangular, right? So that's how we will divide it, and then the axis is basically there, as you can see from the diagram there, where the axis is, right? Should I draw the axis? All right, so because the axis is here, right? And then here, and then here, right? So it's on this surface there. Okay. What else? So we label this with, this is, let's say this is, we'll start from where? This is 1, this is 2, this is 3, right? And 1 and 2 is material A, right? Okay, this is material A, material A, material B, right? Okay, and what we know about material A and B again is, for A, it is, what is it? Brass, right? So equal to 8.74 megagram, right? Megagram is roughly times 1,000 kilogram per meter cube. So material B is raw steel, is it? 7.85 times 1,000 kilogram per meter cube. So of course you can just write megagram per meter cube. I just want to change it to kilogram, hence become like that, right? Okay. So because the column of mass, because mass, how do you calculate mass? If you know the densities as such, then if you multiply by the volume meter cube, then it cancel, it will give you the kilogram, right? So you know from there, it's just basically the density multiplied by the volume, right? The volume is basically, yeah, based on the shape and dimension, right? So because the column is here is to write all of things that is too tight here. So I'll calculate the mass outside, right? So let's take a look at this one. So if I consider block number 1, the segment 1, so what is mass for 1? Mass number 1, right? Okay, let's put it that way. The mass of segment 1, right? So basically the density is this one. So 8.74 times 1,000 kilogram per meter cube. So I just need to multiply by the meter cube, right? So in this case, this one is in millimeter. This is 150, and this is 225 millimeter, right? And then the thickness is 30. The thickness is 30. So it's just multiplication of all those, right? So in terms of meter, so it will be, okay, even this space is not enough. So this is 0.15 for this one. This one is 0.225. Okay, so that one is 30 meter cube, right? So of course, unfortunately, my space is not, my space is no longer, is it still functioning, my space? But anyway, the space there is not enough. So hopefully you understand, this multiplied by that meter cube, right? So if you multiply all of those, you would get something like 8.84, okay, 8.84925 kilogram, right? So it's basically here for segment 1, here is 8.84925 kilogram, right? From that calculation, right? So similarly for mass shape number 2, oops, so for this one here, right? So the density is still brass, so it is still 8.74 times 1,000 kilogram per meter cube, and then you multiply by, what is this length here? This is another 150. So half times 150 times 225 times 30, right? So multiply by half, and then 0.15, and then, okay, again not enough space, 0.225 multiplied by, oh sorry, this 30 is wrong, right? So this is 0.03. Times 0.03, this is meter cube, and then meter cube cancel. When you multiply this, you will get in terms of kilogram. So if my calculation is correct, this will be 4.424 25 kilogram, right? So if you plug in here for segment number 2, 4.424625. Not sure why I'm taking too much decimal point, but yeah, just to give the number there, right? And you can do the same with with the third one. So it's basically just the row for steel multiplied by half times 0.15 times 0.225 times 0.03. And if my calculation is correct again, then 3.974 0625. What is that number? 3.9740625. Okay, so that is the area. Right. So let's go for, so let's go for the centroid, right? So what is the centroid for each of these shape? So for x, for shape number 1, what is the x? Okay, what is the axis again? So x-axis is here, right? So this axis, x-axis is here, y-axis is here, z-axis is here, right? So x-axis, so because centroid is somewhere in the middle there, right? So x-axis here should be half of 150, which means if I take it in millimeter, it will be 75, right? Half of 150. And then y coordinate, it will be in negative side, right? Because it's in the middle of this thickness, so and it's negative side, so it will be negative 15, negative 15, right? And for z is this height, so half of 225 is 112.5. Okay, so that's for shape number 1. What about shape number 2? So it will be somewhere here, right? In terms of x, so this length here should be 1/3 of 150, should be 50 here. But the coordinate will be 50 plus 150 becomes 200, right? And then the y is in the thickness as well, negative side, so negative 15. And z is 2/3 of 225. 2/3 of 225 is 150. Okay, what about this one? So this is should be here. So 2/3 of 150, this should be 100, right? So 100 plus 150 becomes 250. Y is still negative 15. This is because the thickness is standard. And then z is just 1/3 of 225, which means 75. Okay, so that is the numbers. Let me check, right? Should be correct. Okay, the rest is just calculation. So meaning that what will be this value here, here is just straight away calculation multiplication, right? So for example, xm is just x multiplied by m. So 8.84925 multiplied by 75, you get this value here as well, etc. Right? Remember that this negative, it will produce this negative value here. Right? The rest should be positive, right? So you can use your calculator and try to calculate. Let's check whether you have the same answer as mine and double check the value as well. So here, if you add for summation of mass, you get 17.2479, and then xm here, obviously this will be a big number. Is it big number? Quite big number. 2542.135. And then for ym here, it will be like negative 258, negative 258.719, and then for zm here, you get 1957.29. Right, so those are the values. Can you see there? Hopefully you can. So how to calculate this thing is just for x bar, for example, x bar is just summation of xm divided by summation of m, you get the value, right? So basically, for example, here you get 2542.135 over 17.2479. You would get 147.4 millimeter. Right? So do the same calculation with y and z. So just double check. So if my calculation is correct, so this is minus 15, and obviously that should be the answer, because if you get anything other than minus 15, that must be wrong, because when the thickness is standard all through, it should be, and the material doesn't change through thickness, so it should be in the middle of thickness as well. So minus 15 there, and then Z bar, if you calculate 113.5 millimeter, right? So 113 is just above the middle, because the middle is 112.5, right? So is it logical? So if you take a look at the material is heavier in this brass side compared to the steel. So, and this one is a bit above, this one is a bit below, so it should push it above a bit. So it's logical there, right? So the coordinate is X bar, Y bar, Z bar is 147.4, negative 15, and 113.5, right? So you can write it somewhere. I'm out of space there, right? So that is center of mass. What about the mass? So the mass in total is basically just add the 3 mass, right? So you just add, this is basically the total mass, 17.2479 kilogram, right? So we have already calculated the total mass. So we have already answered the two things required in the part A question, right? So looking back at the question, so we have center of mass, we already have the mass, and part B, the question says, is the geometric centroid of the plate the same as the center of mass? So I'll give you 5 seconds to think. Is the centroid same as center of mass? Whatever this answer here, will the centroid be the same? Obviously not, right? Obviously not, because centroid is just it doesn't care about the material, etc., etc. It's just based on the shape, right? So the centroid should be the center of the whole shape, right? So the question says, is it the same? Why? So it's not the same, because for center of mass we have different density at different segment, but centroid is just the center of geometry, right? And then it says, if it is different, determine the location of the centroid. So if you read this question, okay, now it's different. Now I have to determine the location of centroid. What do you think? I need to do this again? Well, actually not, right? Because centroid is just the shape, the center of geometry. So basically, just consider the whole thing, the geometry, right? The centroid must be the center of the thing, right? So it should be, okay, for the centroid, right? It should be the middle there, right? So it should be 150, negative 15, and 112.5, right? That should be the centroid, right? Because it's exactly at the center of the shape. Hopefully you understand that, right? So if you don't, if you any comment, any question, do ask the question in the comment section below, right? So we have done with this question. Let's move on to question number 3. Okay, this is question number 3 for today. We have the diagram on the left. It is basically combination of shape with different dimension as shown, and let's take a look at the question. What it says: locate the center of mass of the block shown in the figure if material 1, 2, and 3 have densities of 7.80 megagram per meter cube, 5.70 megagram per meter cube, and 2.7 megagram per meter cube respectively. So in this question, not only the shape is different, the density is different as well for all the shapes. And then part B, if the location of the centroid of the block is to be determined, will it be the same location as the center of mass determined in part A? Why or why not? Alright, so for this question again, the way we solve it is basically the same. We just make the table, right, and then identify what need to be identified, right? So in this case, we have to locate the center of mass, right? Center of mass, and this is in 3D. So obviously we have X bar, Y bar, Z bar in the end, right? So your answer in terms of the coordinate, right? The equation is X bar equal to summation of X width M summation of mass, and as well for Y and Z, right? So it's the same thing. So basically we'll have the segment and then we have mass, and then x width, y width, z width, and then xm, ym, zm, right? So enough space for the diagram over there. Hopefully you can still see even if it's small there, right? Okay, so we will calculate mass outside of the table again, because we don't have enough space here, right? So to calculate the mass, so we will use the density again, right? So for number one, so for mass, for shape number one, so the density is 7.80. So 7.80, it is in megagram per meter cube. So I'll take it in terms of kilogram per meter cube here as the previous question. So I multiply by 1000 because mega is 1000 kilo, right? So and then multiply by the dimension, right? So this is a triangular shape there. So half times the height is 0.03, and then the width is 0.06 at the base, and then the thickness is 0.02, right? So if you calculate this one, okay, enough space or not? Okay, so you would get, is it 0.14104? 0.1404 kilogram, right? So that's for mass number one. So mass number two, okay, maybe I do not need to show everything, right? So because the step of calculation is exactly the same. So I have the density, which is 5.70 times 1000 if I want to do in kilogram per meter cube, and then multiply by the volume. The volume will be 0.04 times 0.06 times 0.02, right? Looking at the diagram there, right? And if you calculate that, it should be 0.2736 kilogram. And mass number three, so basically it's the base there. The density is 2.7. If you want to do in kilogram, multiply by 1000, and then multiply by 0.06, multiply by 0.06, multiply by 0.02, and then you will get 0.1944 kilogram, right? So that is the calculation of mass. Hopefully you can do, of course, in the exam you have to do in full, so you have to do all the calculation steps. I'm not writing in full because of the limited of space, right? So that's the reason, right? Right, so you just plug in all of this value here, right? So for segment number one, the mass will be 0.1404, right? For number two, mass is 0.2736. So number three, you have 0.1944. This is in kilogram, right? So the rest I will put in millimeter. Now, if you want to ask, right, how come you can put this? This goes to the previous question as well. Why do you put millimeter here when here you have to put in meter? So you have to understand what you are calculating, right? So because this unit here is meter cube, so to cancel the unit, you have to be meter as well. So meter cube can cancel with meter cube, right? So if you put here millimeter, you cannot cancel. Millimeter cube cannot cancel with meter cube. You have to convert, right? You can try that also if you want to convert, and then make sure it get to the right answer, right? But here, it's already not related to what we do inside here, because this already become kilogram. It doesn't have any meter or millimeter or anything inside, right? So this one is up to you, right? Because in the end, if you use meter, you have here meter kilogram. When you divide by kilogram, you get meter. If you get millimeter, when you multiply here, you get millimeter kilogram. Millimeter kilogram divided by kilogram, you get millimeter, right? So it's up to you, and your answer will be accordingly, right? Okay, so X wave. So going, so make sure you get this right, because this is another thing. It is so simple, but sometimes we forget to add to get the actual coordinate. So I write in the different color, right? So for X wave, for the first block, which is on top there, the triangular one, the blue triangular one, what is the X coordinate, right? So the X coordinate should be the thickness, right? Because it's in the middle of the thickness, so it should be 10 millimeter. You get that, right? So the thickness of the triangular block there, right? Because that's X. For Y, based on the triangle, right? So the base is 60, so it should be 1/3, right? Because it's on that side, so it should be 1/3 of 60. It should be 20. All of these are positive. What was Z? Z, if you just focus on the triangle, it should be 1/3 of the 30, right? So it's 10. But because this is coordinate, so you have to add whatever is below, right? So from below you have 20, then plus 40 becomes 60, and then plus 10 become 70. Can you see the red color? You can, right? Okay, so make sure you understand this, right? You have to consider the coordinate, right? Not just the distance itself. So again, so 10 plus 40 plus 20 becomes 70. Right, what about block number 2 here? The X coordinate is still the thickness there, so it should be 10. Y is in the middle, so middle of 60 is 30. Z, middle of 40 is 20, but you have to add another 20 down there, so it becomes 40. Right, for the bottom block there, X will be at the middle of 60 is 30. Y, middle of 60 is 30 as well. Z, middle of 20 is 10. Okay. Yet again, what comes out here is just using your calculator, right? So 0.1404 multiplied by 10, it should be 1.404 here, right? And so on. And then you can calculate what is the summation of mass, summation of xm, summation of ym, summation of zm. Right? If you calculate all of this, then you just plug into the equation, right, for x bar, y bar, and z bar. If you have seen the previous example or question that we have covered, you know exactly what should happen next, right? It's just the step, meaning it's just a repetitive way, because it's straightforward. As long as you get this and this correct, the rest is just calculation. Make sure to note make sure this distance is not distance, this coordinate is correct, as we mentioned, as well as if there's any negative, make sure that you carry forward the negative. That's all, right? Other than that, so if you calculate x bar is xm divided by m, so basically, because over here it should be like 9 point, okay, if I write here 9.972 divided by this one is 0.6084, so they become 9.972 divided by 0.6084, you will get 16.4 millimeter. So for x bar you get 16.4. For y bar, if you calculate, you'll get 27.7. For z bar, you'll get 37.3. So do check and verify all those answers, right? So in terms of the coordinate, you put in terms of coordinate, right? So the final answer is 16.4, 27.7, 37.3, and there you go, right? So normally there will be question from the composite calculation in the final exam, just that we will discuss this in perhaps chapter 10, right? Because chapter 9 and 10, both sections have integration part and composite part, and because the nature is as such, normally if integration come up for chapter 9, then composite will come up for chapter 10, vice versa, right? So that's how normally it is. So I cannot guarantee you that the composite will come up for chapter 9, right? But if it come up, just make a table and solve. It should be straightforward. Alright, so again, part B, we haven't answered that yet, right? Part B, if the location of the centroid of the block is to be determined, will it be the same? So most probably it will not, right? It will not be the same, because centroid is basically the center of the geometry. It doesn't consider any different density, right, and different mass. But for center of mass, it will consider and affected by the different density, right? So if you can see, the density in the question is quite different, 7.8, 5.7, 2.7. So obviously it affects the location of the centroid, the location of center of mass quite significantly. Alright, so hopefully you can answer that question. And we move on to the final question, question number 4. Okay, question number 4. So you have the figure in the left there, quite interesting diagram there, and then we will read the question. Part A, the gravity wall shown in the figure is made of concrete. Determine the location x bar y bar of the center of gravity G for the wall. If the area is divided into segments for the calculation, clearly label each segment. Alright. Part B, propose a way to lower the center of gravity of the gravity wall shown in the figure. There are two constraints to be followed. The height of the wall need to be maintained at 3.6 meter, and the length of the base need to be maintained at 4.1 meter. Justify the proposal. Alright. So in this question, okay, unlike the previous question, this question it is not divided in the question, right? Because if you look at the previous question, it already labeled this is part A, B, and C, right? And you just follow along, right? But here, the way you divide the shape is up to you. And if you look at the shape, you can divide it many different ways, and different students can divide differently. So that's why you have to label it properly, right? So especially for the examiner to be able to follow what is going on. All right. So what we need is the center of gravity, is it? Right. So x bar y bar, because this is 2D. Right. But for center of gravity, if you go to the equation, it is basically using weight, right? But in this question, because it says that the whole thing is made of concrete, so basically it's homogeneous, right? Meaning we can say that there's no difference of density throughout. Hence, the location of center of gravity or center of mass or centroid should be the same, right? The location of centroid is the location of center of gravity. So we'll just use the equation for centroid, which is x bar equal to x with summation of x with times a over summation of a, and y bar is summation of y with a over summation of a, right? So we just consider the area, right? Okay. Right. So what we need is to be able to split the area into segments, right? Now there are different ways of doing this, so I'm just using an example of if I do like this, right? I took a big chunk and then I minus certain chunk, right? So if I minus this one, right? And then I minus this as well. You understand? Meaning that I take the big rectangular, which I label number 1, and then I minus this rectangular number 2, I minus this triangle, and I minus this triangle. That's one way to do it, right? You can also do just take the base rectangle, and then take the triangle, take rectangle, take triangle as well, right? So whichever choice that you do, the answer should be the same, right? So yeah, so you might want to just follow this one first and then try to divide a different way and see whether the answer is the same, and it should be, right? It should be. Okay, so if I divide it like this, okay, so then you will have segment, and then you have area, and then you have x with y with, and then you have x a, and then y a, right? So if you divide like this, so you have four segment, right? 1, 2, 3, 4. So the first segment is just, okay, it's much higher than the width, is it? But anyway, so the big thing is basically the bottom here is 2.4, is it? 4.1. So this whole thing is, okay, how to do this? This whole thing is 4.1 meter, right? And the height, the total height is 3.6, right? So it's basically just 4.1 multiplied by 3.6. You'll get 14.76. Right. Again, all of this calculation will be based on this division. Right. If you divide it differently, obviously all your area, etc., is based on your own diagram. But you can test because the final answer should be the same. Okay. So this is the area, and then what about number 2? Area number 2. So this is, what is it? 0.6, is it? This is 0.6. This is 3, right? This height is 3. Correct? 3. Right. So it will be just 0.6 times 3 should be 1.8, right? Yeah. But because I'm using negative, right? So I minus and minus. So this should be negative area. Right? Hopefully you can see. It's quite small, right? So this is negative area. What about number 3? So this one is, what is it? Okay, to calculate this one is quite interesting because it's not directly given. Right? So what is given is this one is 1.4. Right? So we know this is 0.6. We know this is 1.4. So to get this one, you have to minus. So 4.1 minus 0.6 become 3.5, minus that one become 2.1, right? So it will be half times 2.1 times 3 equal to 3.15. Again, it is negative, so I put negative in the different color here so that it should be obvious that it's negative. And then the triangle there, so this length is 0.6, right? So it will be half times 0.6 times 3, so it should be 0.9, right? So again, this is negative area. Alright, so what about the centroid? So the centroid of the segment, the whole thing, it should be half of this, half of that, right? So half of 4.1 is 2.05, is it? Half from 3.6 is 1.8. Segment number 2, coordinate should be there. X is just half over 0.6, so 0.3. Oh, what is my number there? 0.3. The height. So this is half of 3, so 1.5. But you have to add bottom here, right? Bottom here is, that is 0.6, right? This is 0.6. So 1.5 plus 0.6 become 2.1. For segment number 3, so it should be there. So this should be 2/3 of 3, should be 2 plus 0.6 become 2.6. Right? Oh no, sorry, that's y. So I have calculated y first, 2.6. Right? What about x? X should be 1/3 of 2.1. Or 1/3 of 2.1 is 0.7, right? 0.7 plus 0.6 is 1.3, is it? Okay. What about number 4? So it should be somewhere there. In terms of x, there's several ways to do this, but if I take the n there, it should be 0.2. So the whole thing, 4.1 minus 0.2 is 3.9, right? And then this height here should be 1/3 of 3 is 1. So plus the bottom 0.6 become 1.6. Alright, so that's the coordinate of each segment. So the rest is just calculation, right? This is just using your calculator. Obviously, because of negative area here and all the coordinate is positive, you get negative here, negative, 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 and negative, right? All those value will become negative. And then, as usual, we just add up what we have here, right? So obviously this will be 14.76 minus 1.8 minus 3.15 minus 0.9. You'll get something there, right? So basically, if I just write it down, so this is 8.91. This will be 22.113. This will be 13.158. And the rest is just calculation, right? So for x bar, you'll have XA divided by A, so you have 22.113, 22.113 divided by 8.91, so you'll get 2.48. Right, for Y bar, if you calculate, you'll get 1.48. So in terms of the coordinate, X bar, Y bar, you'll get 2.48, 1.48 meter, something like that. Alright, so there you go. Now, please do verify if you calculate using a different division of segment. It should be the same, the final answer, right? Of course, if you divide, meaning you add, so there's no such thing as negative here, right? So I just want to show if you take a minus area, right? So that will come negative, negative, and negative, just as an example. All right. So now the question says clearly label each segment, right? So do not miss out, because you cannot do this without something of indication. What is area 1 or segment 1? What is segment 2, right? You cannot just jump in on your own. You have your own segment, but the examiner cannot understand what is this, what is this. So you will lose out on the marks, right? Because especially in a question like this, where the segment can be divided in various way, right? Okay. So second part, propose a way to lower the center of gravity, right? And it says the constraint, right? The height should be maintained and the base should be maintained. So what can you do? So there are several ways. This is just to test your understanding, and whatever answer you give, as long as it's correct in terms of the understanding, you will be given the marks, right? So for example, if you change the shape, right? So for example, you make the base more thick, for example, I don't know. And meaning one way is you can redraw, right? For example, the top side here, you I don't know, you make it thinner or something, and then the bottom side become thicker, etc., it can lower the center of gravity. That's one. Number two, if you say make the how to say, the bottom side have bigger density than the top side, hence that also lower the gravity. So anything that, as long as it tally with the understanding, with the correct understanding, you will be given the mark. There's no answer scheme for question like this, because as long as it is correct in terms of the understanding, it is correct. Alright, so moving on to another question. Yeah, we have another question that is not directly related to what we do in the first 4 questions, but I just want to show that that question as well can be solved using composite bodies. Question number 5. Okay, in this question, we have solved this question before, right? Actually, we have done this 2 times. One is when we deal with the chapter where we are dealing with the support reaction. One with the previous tutorial where we calculate using integration, right? So we just want to illustrate that question like this can also be solved using composite, right? So basically, if you look at the question, it is based on this shape basically, right? So you have on the top side you have something like that, and then on the bottom side basically you have the triangle, right? So previously what we done is we take a vertical element throughout, and then we can integrate from the beginning until the end, and then we get the answer in terms of determine the center of mass, right? In this case, center of mass is basically centroid, because the material is the same, right? So so for that one, you can take a look at the previous tutorial, right? How to solve using integration, purely integration from the beginning until the end. But now, if someone want to divide, right? So let's say I want to divide this into 2. Can I do that? Yes, and the answer should be the same, right? For example, if you divide into these 2, and you want to use the same concept, meaning that in terms of composite body, the concept is x bar equal to summation of x with a, summation of a, y bar equal to summation of y with a equal to summation of a, right? You can still use this one, as long as this means what? You have to know the centroid of each, and in this case, the centroid of the triangle is quite straightforward, right? Because this is 2, and this is 2 as well, right? So in terms of that, the coordinate of the centroid of the triangle is just this x coordinate, it should be 1/3 of 2, right? And then this coordinate here, okay, the length first is 1/3 of 2, right? Of course, in terms of the coordinate, this coordinate here, it will be basically from here 2/3, and then -1/3, right? Because in the axis, if you see the diagram, the axis is here, right? So it goes down, so it's negative, so the coordinate is negative there, right? So if you do the table, right, for example, if you do the table, okay, segment, and then area, and then x with y with, for example, and so on. So if I label this segment 1 and segment 2, so for segment 1 and 2, so for 2 here is basically the area is half times 2 times 2, right? Half times 2 times 2 becomes 2 meter cube, meter square, right? And for x wave is basically 2/3, and then for y wave -1/3. Of course, you have what follows, right? X with a, y with a, right? And you know the drill, right? What happened here, what happened afterwards, right? Okay, for this area, unfortunately for this area, you still have to integrate, right? This one. So you can actually do that. For example, you integrate this one. Okay, the equation is what? y square equal to 2x, right? So you can you can do this, and then what? And then you take this one, this is dx, this is y, etc, etc, etc. So if you do the integration, I will not show the integration here because this is from last tutorial. I'm just showing the answer, right? So if you do this integration, basically I think you get for x the coordinate here is, okay, here will be 6/5. Right? This is 6/5, and then here is 0.75. Right? This is 3/4, right? Yeah, this is 3/4. If you want to put, because everything else is in that form, so 3/4. Right, for the area, it's 8/3, right? Yeah, so this one you can verify. You can just do the integration back again. That's the previous portion of the tutorial. I do not want to repeat the whole thing in this tutorial. I'm just showing in terms of if you do this, and then you get the summation of the area, summation of xa, summation of ya, and then you calculate as a total, you will get the same centroid as what we have covered in if you use totally, meaning that the whole shape is being calculated totally by integration as we have done in previous tutorial, right? For example, you take that element there, and then you integrate from the beginning until the end. The answer will be the same. You can verify, right? So I've actually done the calculation, and the answer is exactly the same. So I'm not going to repeat the whole thing. I'm just saying it will be like this, because from here you can already calculate to the end, right? But here, if you just want to practice on your integration skill and how to get the area, and as well as this one, hopefully you still remember the equation, right? Just this is not the chapter, but okay. So x bar is what? Integration of x with dA over integration of dA, right? So it's basically the same concept here, right? This is integration, this is summation. Anyway, so that is it for today. Hopefully you have learned what we need to learn and understand from this chapter, chapter 9, where you will deal with composite bodies, right? Where we divide into sections, and then generally speaking, we just do the table, and then the calculation will be quite systematic, right? It's not compulsory to do the table, but it will be very helpful for you. For example, in the exam, if you want to check your answer, it's quite structured, and for the examiner as well. Do help the examiner so that they will not be stressed out, and for whatever reason that affect the way they mark your paper, right? So with that said, thank you very much. If you are still here until the end, hopefully the quality is good, because of course at the time of this recording, the other kids also have their classes, etc. So you might hear some of the sound. But anyway, if this have been very helpful, do like the video as well. Thank you. So see you in the next tutorial. We will be going into chapter 10 next tutorial, inshallah. Subhanakallahumma bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.